Right, so this is our circuit here that we're going to look at, and we're going to try and get the total resistance of this circuit here. To do that, we need to try and split this circuit into what is a series part, what is a parallel part, and we can deal with them all separately. You can't just use one formula and just do all this at the one time. You need to split it up into different bits. Now, there is certain parts of this that are series, certain parts of this that are in parallel. So you need to decide which bits are in parallel, which bits are in series. So looking at it just now, we can say that if you follow the current from the battery, it comes round here and makes a choice. Everywhere it has to make a choice, of which path to follow, it means it's going to be parallel. So these two here are in parallel with one another. Then the current joins back up again, comes through one little resistor, and then it splits again. So these two are in parallel. So what we need to do, if we work out the total of them, get a number for that. Then we get a total of them, get a number for that. We know that that as a whole thing is in series with that, and then that as a whole thing is in series with that. They're all in series. These four things are in series with one another, one after another. So then all we have to do is add them together. Okay? So what we need to do is work out a total parallel combination of 3 and 6 and a total parallel combination of 12 and 8. Right? So let's do that first of all. Let's look at this one. Let's look at the 3 and the 6. So all we're going to do is this one here. Just this bit here with the 3 and the 6. So to get the total voltage between these two, it's 1 over RT equals 1 over R1 plus 1 over R2. And we just plug our numbers in. 1 over RT equals 1 over 3 plus 1 over 6. Now that's a fraction. 1 over 3 plus 1 over 6. How do we add a fraction? Anybody? How can we add a fraction together? What must we do to the fraction to be able to add them together? Yeah. Common denominator. They must have a common denominator. What would the common denominator be here, John? Between the 3 and the 6. What's a common denominator? A common number that they both multiply into. 3 and 6. 6. So the common denominator is going to be 6. So 1 over RT equals 1 over something plus heat that 1 over 6. In fact, that's not going to be 1 over something, that's going to be 2 over 6. So that's the common denominator. That's the first thing you do, common denominator. Then we just add them together. So 1 over RT equals 3 over 6. Okay? Now, we're going to do a little cheat after this bit to make it easier. All you need to do then is flip the whole thing round. You can cross multiply if you want, but the easiest way is just flip it round. So you take that and you want that at the top, so you do RT over 1 equals 6 over 3. RT equals 2 over 1, 2. So RT is 2. So this whole thing here equals 2. Equals 2. Do we get that? Just an addition of a fraction. Right, I'm going to do the other one as well. If you don't understand that one, I'll do this one. So it's the same formula, 1 over RT. 1 over RT equals 1 over 12 plus 1 over 18. Common denominator for 12 and 18. 36. Is it 36? 36. So how many 12s in 36? 3 and 2. Is that correct? So common denominator, add them up. 5 over 6, 5 over 36. So 1 over RT is 5 over 36. And that means RT is equal to 36 over 5. Flip it over. And what's 36 divided by 5? I've got a calculator handy. 7.2. So that means that this whole combination here equals 7.2. So now we've got 7.5, 7.2, 3 and 2. So the total resistance of the whole lot is just add them together. So total resistance, R total, is going to be equal to the 7.5 plus the 7.2 plus the 3 plus the 2. And that would, you just add them up, because it's a series circuit then. Just add up that, and this whole thing, and that, and this whole thing. Because you've just got the parallel combination of them all. Now, Ben looks confused. Anyone else look confused? Anyone else feel confused? Are you confused? John, a bit confused? Okay. Now it's just maths. It's adding up fractions and getting all your total value for series and parallel. Okay? It's not easy. This does confuse a lot of folk. What a lot of people forget to do is flip it over at the end. Now, do you understand why I'm doing that? I'm going to show you why I'm doing it. Okay? So let's look at 1 over RT equals 3 over 6. So 1 over RT equals 3 over 6. If I cross multiply this, then I get 3RT equals 1 times 6. Everyone see that? Cross multiply. 3 times RT, 1 times 6. And then that means that RT equals 1 times 6, which is 6 over 3. Did we get that? So cross multiplying gets you this, and then you just rearrange it. So rather than going from here and doing all that in between, you can just do, okay, 1 over RT is 3 over 6, so RT is going to be 6 over 3. Flip it over. Just flip them round.
Is that like what we did with the letters and that?
The letters, like, you do X and Y and cross multiply. Exactly the same, it's just cross multiplication. Now that does confuse folk. I know it does. And you'll only get this in a credit paper.